CullingGroup API disables scripts when objects are off-screen. Hello and welcome to episode number 29 of the Unity Performance Task Force podcast. I'm your host, Ruben from TheGameDev.Guru, and as usual, I'll kick things off with a question for you. Have you ever profiled your game and realized expensive enemy AI scripts are running even when you're staring at a wall? Sounds familiar? If so, this episode is for you. In Unity, you usually have one camera. Whatever is not visible, for example, because it's behind a camera, is still processing in the background. It might not be rendered, but scripts still execute. Update loops don't get automatically disabled by magic. CullingGroup is going to help you get rid of this. Unity does something similar for rendering. If an object is not visible behind a wall or behind a camera, Unity applies occlusion culling or frustum culling. Unity doesn't render that object, doesn't prepare draw calls, doesn't send anything to the GPU. This is done through bounding boxes of your renderers, and it happens automatically. But scripts might still run, costing milliseconds on your CPU. Do you need to run all these scripts if objects are not visible? Animators, do you need to run animations if the object is not visible? This is where CullingGroup helps. It tells you whether an object is visible or not, so you can start or stop executing scripts. Basically, you ask Unity to give you updates on whether these objects become visible or invisible, and you act accordingly. Normally, you enable or disable a specific enemy object or component, but you can do any custom logic gameplay stuff too. This is a performance-focused lesson, but you can be creative. For example, if you know a point is not visible, you can spawn monsters there so the player doesn't see the spawn. You can disable AI computation if a specific enemy is not visible, especially if it's in another room. Do you need to check for player visibility? Do you need to cast so many rays? Maybe not. So how do you use CullingGroup? Here are the steps. First, study your use case. Does it make sense to spend time implementing this? If objects don't cost anything, the answer is probably no. But if you have expensive scripts you don't need when objects are invisible, like raycasts for AI, then consider it. Also, calculate or guesstimate the potential performance gains. Every time you ask Unity for something, it costs performance. But the CullingGroup API is not especially expensive. I've used hundreds of these probes and didn't notice any specific drop in performance. Usually the gains are superior to the cost. Once you have a solid use case, create the CullingGroup. Second, assign the right parameters. Unity requires some information. You need to tell Unity which camera to test visibility against and which volume bounding spheres to check visibility against. Right now, we only have access to spheres. Third, Unity tells you whether objects become visible or invisible. This is the main point where you do everything. Fourth, when you're done, dispose the CullingGroup. Let's see this in Unity. I have a project where the enemy controller.txt update is taking about 3 milliseconds every frame. That's expensive. Let's assume it makes sense to optimize this. Let's assume we don't want enemies to run around if we don't see them. So, let's implement CullingGroup for the enemy controller. First, create a variable CullingGroup. Second, initialize it in start. CullingGroup new CullingGroup. Third, dispose it in onStart, CullingGroup.spast CullingGroup null. Setting it to null helps the garbage collector clean it up faster. Fourth, assign parameters. Set the target camera, CullingGroup.targetCamera camera.main. Fifth, set the bounding spheres. Create an array of bounding spheres, spheres, new bounding spheres, new bounding sphere transform.positioned 0.5f. The position is the enemy's position. The radius is 0.5 meters. Then assign the array CullingGroup.setBoundingSpheres spheres. CullingGroup.setBoundingSpheres count spheres.length. Sixth, update the bounding sphere positions every frame. The enemy moves, so the sphere position needs to update. Create a method update bounding spheres and call it in start and update. Seventh, assign the callback. When the object becomes visible or invisible, Unity calls your function. CullingGroup.onStateChanged equals event in braces enabled equals event dot is visible. This enables or disables the script based on visibility. Now let's test it. Add a debug.log to see when visibility changes. Debug.log $, quotation marks, game object.name became visible. Event.is visible. End quote. Play the scene. Look at a wall. If you did everything right, the fixed update shouldn't be called much because enemies aren't visible. Look at the center of the map. Now you see blue lines. Fixed update is kicking in. So let's recap. First, we studied the use case. Enemy controller.fixedUpdate was expensive, 3 milliseconds per frame. We decided we didn't want AI to happen when enemies were not visible. We estimated we could save up to 3 milliseconds per frame when looking at walls or elsewhere. Second, we created a CullingGroup instance. Third, we assigned parameters, the camera, the bounding spheres, and updated sphere positions every frame. Fourth, we assigned the onStackedGameDev callback. We asked Unity to let us know when the object becomes visible or not, and we enabled or disabled the component accordingly. Fifth, we disposed the calling group when enemies were destroyed. Now some other tips. You can do custom logic. You also get the distance at which something is. Check the API for more. Calling group is not only for performance, you can be super creative. The main question, do you need to execute these specific scripts if the object is not visible? One more thing. Calling group is not necessarily coupled to one specific object. You can create a cluster of objects or put a bounding sphere somewhere else and execute logic in a different spot. There's no one-to-one relationship required. You can cluster enemies together into one sphere. You can also add more bounding spheres to one calling group if your use case requires it. For example, in my project, when I'm looking at a wall, enemy controller.TextUpdate doesn't run. When I look at enemies, it runs. This saves 3 milliseconds per frame when enemies are off-screen. So to sum up, calling group tells you when objects are visible or invisible. You can disable expensive scripts, spawn enemies off-screen, or do any custom gameplay logic. Study your use case, create a calling group, assign parameters, and act on visibility changes. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity Consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time.